Welcome to Engineering Simplified. Have you ever wondered how engineers calculate the voltage, current, or resistance in an electrical circuit? The answer is one of the most important and widely used principles in electrical engineering, Ohm's law. In this video, we're going to break Ohm's law down step by step and make it simple to understand. We'll learn the relationship between voltage, current, and resistance, how to use the Ohm's law triangle, and how to rearrange the formula depending on what we need to calculate. We'll then work through examples of calculating voltage, current, and resistance. After that, you'll get 3 viewer tests to try for yourself before we work through each answer together. But before we start calculating, let's look at the man behind Ohm's law. Ohm's law is named after Georg Simon Ohm, a German physicist who lived from 1789 to 1854. Through his experiments with electrical circuits, Ohm discovered the relationship between voltage, current, and resistance. His work showed that the current flowing through a conductor depends on the voltage applied across it and the resistance opposing that current. The unit of electrical resistance, the ohm, represented by the Greek letter omega, was named in his honor. Now let's look at the Ohm's law triangle. The triangle contains 3 quantities. V represents voltage, measured in volts. I represents current, measured in amperes or amps. And R represents resistance, measured in ohms. The basic Ohm's law equation is V equals I multiplied by R. The triangle gives us a simple way of rearranging this equation without having to memorize 3 separate formulas. Here's how it works. Cover the value that you want to calculate. If we cover V, we are left with I multiplied by R. So voltage equals current multiplied by resistance. If we cover I, we are left with V divided by R. So current equals voltage divided by resistance. And if we cover R, we are left with V divided by I. So resistance equals voltage divided by current. It's a very simple technique, but it makes using Ohm's law much easier. Now let's put it into practice. In our first example, we need to find the voltage. We have a current of 5 amps and a resistance of 12 ohms. We're looking for voltage, so we cover V on the triangle. That leaves I multiplied by R. Our formula is therefore V equals I multiplied by R. Substitute the values into the equation. V equals 5 multiplied by 12. 5 multiplied by 12 equals 60, so the voltage is 60 volts. In other words, a voltage of 60 volts will drive a current of 5 amps through a resistance of 12 ohms. Now let's calculate current. In example 2, the voltage is 48 volts and the resistance is 12 ohms. We need to find the current. Cover I on the triangle and we are left with V divided by R. So I equals V divided by R. Substitute our values. I equals 48 divided by 12. 48 divided by 12 equals 4. Therefore, the current is 4 amps. This means that when 48 volts is applied across a resistance of 12 ohms, a current of 4 amps will flow. For our third example, we're going to find resistance. The voltage is 36 volts and the current is 6 amps. Cover R on the triangle. We are left with V divided by I. So R equals V divided by I. Substitute the values. R equals 36 divided by 6. Therefore, the resistance is 6 ohms. Before we continue, if you're finding this video useful, please take a moment to like the video and subscribe to Engineering Simplified. And leave a comment below telling me what engineering or maths topic you'd like me to explain next. Every like, subscription, and comment helps the channel grow and allows us to make more engineering videos like this one. Now let's look at where Ohm's law is actually used in the real world. Electricians use it when installing and troubleshooting electrical circuits. Electronics engineers use it to calculate component values and ensure circuits operate correctly. It can be used with motors and machinery to understand current, voltage, and resistance. It is also fundamental in power distribution, where engineers analyze electrical circuits, cable resistance, voltage drop, and current flow. And it is used when working with batteries and energy storage systems. So although the equation itself is simple, its applications are enormous.
Now let's look more closely at the relationship between voltage, current, and resistance. Remember, V equals I multiplied by R.
If resistance remains constant and we increase the voltage, the current increases. For example, if we double the voltage while keeping the resistance the same, the current will also double. Voltage and current are therefore directly proportional when resistance is fixed. But resistance behaves differently. If voltage remains constant and we increase the resistance, the current decreases. For example, doubling the resistance while keeping the voltage constant will halve the current. Current and resistance are therefore inversely proportional when voltage is fixed. So voltage, current and resistance are all interrelated, but they are not all proportional in the same way. Now it's your turn. Viewer test number 1. Find the voltage. The current is 8 amps and the resistance is 15 ohms. Pause the video now, use the Ohm's law triangle, and see if you can calculate the voltage yourself. Ready? Let's work it out together. We need voltage, so our formula is V equals I multiplied by R. The current is 8 amps and the resistance is 15 ohms. Substitute those values. V equals 8 multiplied by 15. 8 multiplied by 15 equals 120. Therefore, the answer is 120 volts. If you got 120 volts, well done. Now for viewer test number 2. This time, find the current. The voltage is 230 volts and the resistance is 46 ohms. Pause the video and work out the answer. Ready? We need current, so the formula is I equals V divided by R. Substitute the values. I equals 230 divided by 46. 230 divided by 46 equals 5. Therefore, the current is 5 amps. If you got 5 amps, you've got it right. Now let's try the final viewer test. This time, we need to find the resistance. The voltage is 24 volts and the current is 3 amps. Pause the video and see if you can solve it before we reveal the answer. Let's work through it. We need resistance, so the formula is R equals V divided by I. Substitute our values. R equals 24 divided by 3. 24 divided by 3 equals 8. Therefore, the resistance is 8 ohms. If you got 8 ohms, well done. So, what have we learned today? Voltage is the electrical potential difference that drives current through a circuit, and it is measured in volts. Current is the flow of electric charge through a circuit, and it is measured in amperes or amps. Resistance is the opposition to the flow of current, and it is measured in ohms. The fundamental Ohm's law equation is V equals I multiplied by R. To calculate current, we use I equals V divided by R. And to calculate resistance, we use R equals V divided by I. The Ohm's law triangle gives us a quick and simple way to remember all three equations. We've also seen that increasing voltage increases current when resistance remains constant, while increasing resistance decreases current when voltage remains constant. Ohm's law is one of the foundations of electrical engineering, and once you understand the relationship between voltage, current, and resistance, you have a powerful tool for analyzing electrical circuits. If you found this video useful, please like the video, subscribe to Engineering Simplified, and leave a comment below. Your likes and comments really do help the channel grow, and if there's an engineering, electrical, physics, or maths topic you'd like to see explained next, let me know in the comments. Thanks for watching, and I'll see you in the next Engineering Simplified video.